Hey guys, it's Miss Lackey. In this video, we're going to be looking at how to name molecular compounds and how to name hydrates. So remember, molecular compounds are going to be between two substances that are both non-metals. So these are in that top right part of your periodic table. So the formula and name of a molecular compound are going to describe the type of atoms present and the number of atoms present in the compound. Generally, whenever they're listed, the most metallic element appears first in the name. That's going to be the one furthest to the left of the periodic table or closest to the bottom. And then the second element will be named with the root of the name and the ending of IDE. So similar to ionic compounds, and that only occurs on the second element that we're naming. How this is different from ionic is that each element is going to have a prefix that describes how many atoms of that element you have in the compound. The only time you're not going to see a prefix is if there is one of the first element. It will not have a prefix if it's the first element and there's only one. So for example, if the first element is N1, we would simply say nitrogen instead of mononitrogen. Make sure that you go and review the first 10 prefixes. This we're going to use consistently with our different naming types, at least for molecular compounds. So mono means that there's one of that element. Di means that there are two of that element. Tri is 3. Tetra is 4. Penta is 5. Hexa is 6. Hepta with a PT is 7. Octa is 8. Nona is 9. And deca is 10. So feel free to pause if needed and write down these prefixes because we're going to use them with some examples in a moment. So whenever you're writing formulas, because we're still going to use the same rules, you're going to write the symbols for the elements in the order that they appeared in the name, and the prefix tells you how many of each element you have, so the prefix will tell you what subscript you need with each of the elements. And yet again, if your subscript is 1, you do not have to write that. So let's practice some of these. And we're going to walk through them bit by bit. So the first one is N2O4. So we said you want to name the first element, and you don't change the name of it at all. So the first element is N, which is nitrogen. And it has a prefix to tell you what the subscript is. So since it is N2, the prefix for 2 is di. So this will be dinitrogen. And then O4, and remember the second element, we're going to change the ending to IDE. So O would be oxide, and since the subscript is 4, we need the prefix for 4, which is tetra. So this will be tetroxide. So that will be dinitrogen tetroxide. Sorry, there's a delay from my iPad to the screen. Look at the second one, NO2. N is nitrogen, and there is only one of them. So remember, if our first element only has one atom, we do not give it a prefix. We will just list it as nitrogen. But then O2, O is oxide, and then the 2, the prefix is di, so this will be dioxide. So that is nitrogen dioxide. Look at our third example. We have water, which is H2O. Water is its common name, so let's look at its proper name. So H2, H is hydrogen. Remember, we don't change the name of the first element. 2 is di, so this is dihydrogen. And then O is oxide, and since there is only one and it is the second element, we do have to give it a prefix. So this will be monoxide. So the second element will have the prefix of 1, the first element will not. Let's look at the next one. We have N2O6. N is nitrogen. The subscript of 2 means that it is dinitrogen. And O6. O is oxide, but the prefix for 6 is hexa. So this is going to be hexoxide. All right, I want you to take a moment. Feel free to pause. Try the next one on your own. We'll come back to it in a moment after going over writing formulas. So the first one that it gives us the name is tetracarbon dekiodide. So tetracarbon, tetra means 4. Carbon symbol is C. So this is C4. Dekiodide. So dec is 10, and iodide is from iodine, so I, so this will be I10. And note that we do not reduce these like we did ionic compounds. We leave them as is. Let's look at the next one. Diphosphorus tetrafluoride. Diphosphorus, di is 2, phosphorus is P, so this will be P2. Tetrafluoride, so tetra is 4, fluoride is F, so this will be F4. Take a moment, feel free to pause and try the last one, the trisulfur heptachloride on your own. In the meantime, let's go back to the one that you tried on your own, the P3O8. So P3 should be triphosphorus. O8 is going to be oxide. And let's go down to the last example you tried on your own, the trisulfur heptachloride. So tri means 3, sulfur is S, so this will be S3. Heptachloride, so hepta is 7, chloride is Cl, so this will be Cl7. So make sure to try this in your homework practice as well. Let's move on and look at hydrates. Hydrates are compounds that actually contain water of hydration. So they're actually bonded water molecules within the formula itself. These can be heated to boil off the water, producing an anhydrous powder, one without water. And then you can actually add water to recreate the hydrate. Hydrates combine our ionic compounds with our molecular naming rules, essentially. So whenever we're naming a hydrate, we're going to write the name of the ionic compound first. There's generally a dot between the ionic compound and the part that's the hydrate, the water. And then we're going to write the number of water molecules per formula unit. And this will be using our metric prefixes from molecular naming. So I have a couple examples shown here, and then we'll do some together on the next slide. So for example, if we have copper 2 sulfate pentahydrate, we would write the formula for copper 2 sulfate, crisscrossing our charges as needed, put a dot to signal that it is attached to the pentahydrate. Penta is 5 and hydrate is water. So it is CuSO4 dot 5H2O. You can also go the opposite direction and name these from the formula. So if we have CoCl2 dot 6H2O, CoCl2 is cobalt and chloride, but remember cobalt's a transition metal, so it needs the Roman numeral for the charge. So this is cobalt 2 chloride, and 6H2O, 6 is hexa, so it is hexahydrate. Let's look at a couple examples together. So our first one we have is MgCO3.7H2O. So remember, we're going to name the ionic compound first, so just focus on the MgCO3. Mg is magnesium. CO3, remember, is going to be one of our polyatomics that is carbonate. And then 7H2O, remember 7 is hepta, so this is going to be heptahydrate. Look at our next one. We have barium hydroxide octahydrate. So barium hydroxide, remember barium is Ba with a positive 2 charge. Hydroxide is your polyatomic OH with a negative 1 charge. So when we crisscross that positive 2 and negative 1 charge, we get BaOH2. Remember, you have to put parentheses around the OH. And then octahydrates, remember you put a dot connecting it to the hydrate. And then octa is 8, so this will be 8H2O. So BaOH2 dot 8H2O. Let's look at our next one. We have FeSO4 dot 7H2O. So look at the ionic compound first. Fe, remember, is iron. Iron is a transition metal, so we are going to need our charges in Roman numerals. SO4 is sulfate. So remember, sulfate has a charge of negative 2. So iron here must have a charge of positive 2. So this is iron 2 sulfate. And 7H2O, the prefix for 7 is hepta. So this is heptahydrate. All right, look at the last one. We have sodium sulfate decahydrate. Sodium, and I'm going to write this down below, is Na with a positive 1 charge. Sulfate is SO4, and remember that has a negative 2 charge. So when we crisscross that positive 1 and negative 2, we get Na2SO4 dot, and we have to include our hydrate. Remember, deca is 10, so this will be attached to 10 water molecules. That concludes molecular naming and hydrates. Make sure to practice these on your homework sheet.